Hi guys, so I will be taking you through the Studio NPVS 2.1 allocation and flow module today. We will be optimizing our life of mine scheduling with stockpile management. So my name is Sophie Mellor. I am a consulting mining engineer with Datamine, but I actually started my career as a graduate mining engineer with Rio Tinto. So I am a fully certified quarry manager. So I've been with Datamine for about 2 years, and I normally specialize in the Studio suite of products, so Studio OP, Studio NPVS, and Studio RM, and Studio EM is one of our more recent ones. I also touch base on Data Blast and give people a hand with that one as well. So we have a series of integrated solutions. We go from exploration all the way through to environmental sustainability. So this particular product, Studio NPVS, is part of our planning suite products, but we also have a series of production, laboratory and sustainability products that we also do. So this particular webinar will be covering the following areas: mine inputs, single mine stockpiles, multi-material stockpiles or destinations, global targets, and optimization selection. We will also be giving you a quick preview of Studio NPVS Plus. So Studio NPVS Plus is the big brother of Studio NPVS essentially. So it has a brand new algorithm and a completely different layout to Studio NPVS. So that's been one of our major projects over the last couple of years, and we will be introducing that very, very shortly. Hello everyone, and welcome to the Southwork project. This is a project that I generally use to demonstrate some of the higher level NPVS functions. So my previous webinar, I actually took everyone through the scheduler function, and this webinar I am going to be taking everyone through the allocation and flow function, also known as the blending module. So we will be all about grades, tons and targets for this particular module. In order to bring up my previous work for this particular project, I simply went optimization, show and reports, and it allowed me to bring up all my tabs demonstrating that all the previous data is still in this project, and we will be using this data moving forward. So we do already have a bulk schedule for this particular project, but now we will be moving into the blending aspects of this project. Okay, so the allocation and flow module basically consists of a series of panels. So there's the mine inputs panel, which assists you in generating grade classes, also known as grade bins. So the grade bins are required for the linear optimizer to generate optimum results. The Stockpiles 1 tab allows you to create stockpiles that accept only one rock type and put in all the stockpile parameters regarding that particular stockpile. Stockpiles 2 allows you to generate stockpiles that accept multiple rock types and allow you to enter in all the parameters associated with those stockpiles. Destinations allow you to configure all your destinations, such as your process plants and your stockpiles, and set grade or quality targets. The global tab allows you to generate global targets for your particular mine site, and it also allows you to generate reporting variables. So I'll demonstrate that going forward. And optimization allows you to select which of the optimizers you would like. Mellor, so the material allocation optimizer, so that's very much the blending optimizer that'll generate optimum NPV at specific blends and tons. And then you've got the MFO optimizer, so that's very similar to Mellor, except that you can enter in the maximum amount that you can mine across the mine site, and it will generate or check to see whether you can generate a higher NPV simply by maxing out your mining fleet. So the flexible material scheduler, it just schedules pushbacks and optimizes material allocation. So I will be demonstrating a couple of these today. Please stay for the remainder of the webinar. In order to ascertain our AU and CU grades, we should probably check the results from our previous runs in Scheduler. So I'm just going to say cancel here for a second, and I'm going to take us back to the schedule. So you can see here we have a minimum gold grade and a minimum copper grade. So I'll be using these numbers to enter into my mine inputs. So in this case, I want for trans ore, top one, I want the total value of all products, and the minimum grade I'm going to say is 0.0203. The max grade I will say is 5. For copper, I want 0.050. Max grade of 3. For fresh, again, total value of all products, I would like 0.07037 and 3 and 0.0013 and 1.9. So this will give us the ranges we would like, and then you have to specify how many bins you would like, or grade classes. So I think I want 52 for both. So that just teaches the program what sort of resolution you would like your data to come through in. All right, stockpiles. We also want a couple of stockpiles, and we want high grade and low grade stockpiles. So we not only want stockpiles, we want our stockpiles to have certain grade ranges. So I'm going to say create all stockpiles in one go, and I'm going to say SPLG. All our stockpiles will have a storage capacity of 50 million tonnes, a max reclaim rate of 4 million tonnes, and a rehandling cost of 0.35. So I've decided to create stockpiles for all types in one go, so I only have to do one set of LG and one set of HG. This just speeds up how quickly I can generate my stockpiles. So as you can see, we now have a SPLG trans stockpile, SPLG fresh stockpile, and SPHG trans and SPHG fresh stockpile. They all have the same parameters: storage capacity of 50 million, max reclaim rate of 4 million, rehandling cost of 0.35, and stockpile product recovery adjustment of 1. If I wanted to, I could specify that the parameters vary over time. So I could literally say if I wanted it year 1, year 2, year 20, for example, I could adjust all the figures in here. But I think I'm pretty happy with them as they are. I could also add an initial stockpile content if I was building a stockpile on top of remnants, which I'm not in this particular case. So stockpiles 2 allows you to, and I'm just going to demo this. We will not be using this particular tab for this project, but I'll just give you a quick demo of this one. So I want, and I can say stockpile accepting multiple rock types and say OK. And then you just simply add the rock types you would like. And then you can specify reclaim limit, reclaim cost, recovery adjustment, for example. You can also specify whether or not the parameters vary over time, similar to stockpiles 1, and also if you're building over remnants, you can also specify initial tonnes, volumes, and grades. And you can also check that the process material is destined for and enter required data. So you can specify in a little higher level for stockpiles 2 than you can for stockpiles 1. Something else I should probably mention is if you're sending material from an external source to your mill, you can also generate it as a stockpile. So you can say SPUG, and that will generate material to be sent to our particular mill from an external source. I'll just hit cancel and I'll delete that one because we're actually not using this particular tab for this project. So I now have all my destinations and I need to specify how much material is going to these destinations and or their grade constraints. So I'm going to say, first up, I want more options and I want to define it. We want year 1, year 2 and year 20. This particular project has a mine life of about 11 years. So 20 is a nice end year for your stockpiles. You want to have your stockpiles still active after your mine life, just so that if they have any remnant tons left on the stockpiles, even after mining ceases, that those tons can still be sent to your mill so you don't lose any material. So just heads up, do remember that your stockpiles should be active for longer than the life of your mine. In this case, I want 13,500 per day, so times 365 equals 427, 4927, 500. But I actually want to divide this number by 2 because in the first instance, my end year of 2, I want it at a half rate. So I don't want anything to be milled in the first year. Everything is just sort of doing pre-strip, etc. But second year, I want a rate of 2463, 750. And every year after that, once it's ramped up to full rate, I want 4927, 500. And then I'll go OK. And I'll just double check the grade constraints for this one. So for all my stockpiles, I want them to have slightly different grade constraints. So I want SPLG Trans and SPLG Fresh. They're low grade stockpiles, so I want them to have a maximum grade of 0.5. Whereas for my SPHG Trans and SPHG Fresh, I want them to have a minimum of 0.5 because they're high grade. And I want all of them to be stockpile only or reclaimable at a profit. So if I can't make a profit out of the ore and sending the ore to the mill, then it's waste. I don't want to waste any more time or money on material that will not make me profit. I will leave the global tab just for a second and I will switch us over to optimization. So we are currently running Mayo. This is what I do recommend when you do your first pass, just to have a good look at all your numbers. And then once you've run Mayo and you're happy with the numbers you're producing, then I recommend you switching to MFO, just to see if you can further optimize your processes. But I'm pretty happy with what I've generated thus far. So I'm going to hit run. So I will just be taking you through the results. Going to hit OK here. And as you can see, it's brought up your mines total. We're mining about 10 million tonnes per annum. It tells you how much of that is ore. So the amount you mine as ore will differ from year to year depending on your ore waste ratio. So in the first year, we'll have 0 ore coming from stockpiles and then it'll start ramping up. and then back down again. It'll give you your rehandling cost, just to let you know how much your money it's costing you to rehandle from the stockpiles. Mining cost, processing cost, NPV, we're currently generating in this project 272 million, of which 484 million of that is profit. Mill volume and ore tons. So again, we're hitting those targets that we actually set in terms of our destination targets. It also gives you mill AU recovery, so how many grams you can expect to get year on year. Same with copper, CU recovery. And it gives you a whole bunch of information on the stockpiles. So for example, first year, because we are mining but we are not processing, the vast majority of the material that we're mining is actually going to the stockpiles. So 641,000 approximately is going to the XPLG trans ore stockpile. SPLG fresh is getting no tons, possibly because they're not mining fresh ore at that particular point. Okay, 782,000 is going to the SPHG trans ore stockpile in the first year. And there's no material going to the SPHG fresh ore stockpile in the first year. So this does give us a fair amount of information. One thing I do generally check is to see how much ore that's been deemed economic has actually been dumped because it doesn't make a profit. So there is a certain amount of ore tons that are dumped every year just to fully balance it out, and that shows up in the total dump tons. Okay, so if you do a quick balance, you'll find that all the numbers work out nicely, but they're not organized in a manner that I would really appreciate. So I am going to generate my stockpile evolutions. I'm going to come up here to optimization options. I'm going to select Mayo MFO. I'm going to select both incremental data and stockpile evolution, and I'm also going to remove the rescat because I don't think that information is really relevant in this case. And then I'm going to hit OK. And then I'm going to come to reports, and I'm just going to regenerate this report. And now I have a slightly better set of stockpiles. The SPLG trans ore tons, the tons coming in, tons coming out, so off the stockpile. That's rather handy. And I have it for also LG fresh, or in, or out. How the grades are changing. In addition, we've also got SPHG trans ore. So in and out as well, and SPHG fresh. So those tons, and of course grades. And what's coming in and what's going out. So as you can see, the stockpile evolution gives you a good overview of your stockpiles. One thing to note is that the tons coming out in terms of LG only actually starts in about year 4. So that means that the HG, for the first couple of years, the HG stockpiles are being prioritized. So as you can see, SPHG trans ore out for the first, say, 4 years, that's being prioritized, and then it's only a little bit is given priority after that. So yeah. And you can kind of see that resulting favoritism of the high grade in the early years is actually shown in our mill grade. So you can see we've got average mill grade of 1.3 and then 0.9, 0.68. So you can basically see it very high in the second year and then falling after that until it maintains about 0.75. So you can actually generate slightly more accurate mill tonnes. At the moment, it's pretty variable. So we're ranging from 1.3 grams per tonne coming into the mill up to 0.7. So if you wanted to smooth those rates, it does that simply because it gives you the best NPV. You want to process as much gold as possible in the early years, get a decent swag of money at the very start of your project, because money at the start of your project is worth more than money at the end of your project according to NPV. So if we want to adjust that, you can actually see the difference. If we want, say, steady state across, or reasonably steady state over the first 3 years, and then again steady state for the next couple of years at a lower grade, we can actually simulate that in this particular project. So I'll be demonstrating that with a new scenario. Okay, so we are going to quickly create a new scenario. So I'm going to just take this one, add, and I'm going to call this Mayo 0.9 to 0.7. I'm going to click OK. Then I'm going to take the settings and copy them and then paste them to this one. And I think I'll rename this one while I'm at it. So this can be Mayo. And then I'll double click on this one just to activate it. So I'm jumping back into allocation and flow, and I just want to add a quality target to my AU. I'll just call it AU grade, 20 or 20. In fact, I think I'll do 3 years at 0.9 and then 20 at 0.7. And I'll hit run again. And we're going to hit OK. And I'll go across to see what my mill is up to. Here we are. Okay, so we've got the tonnes, but as you can see, our mill ore tonnes have dropped slightly. And we are, first year is 0, second year is roughly 0.9, third year is roughly 0.9, and then it's very close to 0.7 for the rest of the years. But yes, in this case, it has followed the procedure, but it is losing tonnes. It's losing about 3 million tonnes from what I can gather. So hold on, I'll just check the original. Yeah, so the original was 50 million tonnes approximately for mill ore. But with the grade constraints, it's dropping to about 47 million. So that's not ideal in terms of mill ore tonnes, but I just want to see while I'm here if I can see the ROM ore tonnes. So I'm going to set another target, and I'm going to say I want to generate targets using the processing rate, so that'll just give me all of my processing targets. And I just want to edit this one, and I want to say ROM ore This is essentially a dummy target. I just want this target simply to generate a variable for me that prints out at the very end. Just want to know how many ROM tons we're generating. I'll just delete these ones because they're not actually required. Please note that this is not ticked, so it's not actually controlling anything, it's just printing results. And I will hit run again. And if I come all the way across, it's giving me a new variable called ROM ore. Simply because, yeah, we are losing a little bit of tons, and I just wanted to look at that in greater detail. So overall, while our grades have a higher level of control over them, I actually make more NPV with the original project. So because we're losing tons, if I go across to NPV, we are at 239 million. Whereas I believe the previous one, we were up near 272 million. So I'll just double click on this one. Yes, so yeah, we've gone from 272 million to 239 million. So I'm not overly fond of that. So we will just sort of ignore this secondary project. And instead, I will go into optimization and flow. So instead of Mayo, I will do MFO now. I'll just create a new project. So yeah, I want to swap from Mayo to MFO with the original scenario. So in this instance, I actually want to select MFO and I want to set the maximum mining rate. I want tonnages coming from the mine and reclaimed from stockpiles. I want NDO to be 20 and I want the maximum mining rate we can do is 15 million. We generally sit on about 10 for this project, but we can, with our fleet, mine up to 15 million tonnes. And I want to basically check whether mining extra material will get us a better NPV at the start of the project. So we'll hit run. Okay, so in this instance, the MFO scenario has managed to boost our NPV to 275. And if we come across to summaries, Mayo MFO, it has managed to boost our NPV to 275 by mining about 3 million more at its top mining rate than the previous Mayo example. So we haven't hit 15 million tonnes, but we've gotten pretty close to 13 million. So we are definitely ramping up our mining rate at the start of the project just to generate additional NPV. It's just chasing higher grades at the start of the project from the looks of it. So if we hit back to legacies, our total mining rate in the first couple of years is 13 million for the first year, 11 million for the second, and 10 million for approximately all the years after that, with a slight slowdown in years 10 and 11. You can also check all your stockpiles in terms of their grades. So the Transor stockpile is accepting far more tonnes. In the first year from this scenario, it's bumped from about 641 to 1.1 million tonnes in the first year. SPLG Fresh, still 0. SBHG Trans, zero in the first year, 1.4 in the second. So coming in is 1.4 as well for HG Trans. And fresh ore starts at 0. Yeah, fresh ore doesn't really come in until year 3, HG Fresh. Okay, so yeah, that's basically a quick overview of this particular project. It demonstrates how we can use Mayo to control our grades and then MFO to check what an increased mining rate will do to our NPV and the optimum mining rate to generate the optimum NPV, which in this case is 13 million tonnes per annum. So your fleet should be able to get at least 13 million tonnes per annum. And it also gives you an approximate mine life of 12 years, both for Mayo and MFO. So I'm also just going to quickly take you guys through a bit of a Studio NPVS preview. So Studio NPVS is a new product that we are intent to bring to market. It basically contains the most powerful mine planning solver. It's so powerful that we're actually going to be combining the scheduler function, the allocation and flow function, so both Mayo and MFO, into one product called Scheduler in brackets Maroma. So it supports multiple parallel constraints simultaneously, and it's capable of dealing with variable length periods. So we'll be setting this up in a simplified workflow coupled with an easier and more intuitive graphical user interface. This will also support multi-mine functionality, so you can schedule between different block models. Okay, so Studio NPVS preview. On the left-hand side, you've basically got the new interface. It's a lot cleaner and a lot easier to click through the different tabs, I guess you could say, and display all the data as required. On the right-hand side is the previous scheduler settings, and it just gives you an idea of just how much cleaner the interface will be between the two different applications. Please note, we will still be supporting NPVS. NPVS Plus will just have far more power and, yeah, a slightly different graphical user interface just to make everything easier. So this is an example of your pushbacks panel, and the new one is on the left-hand side. Again, the old is on the right. So this is just determining your pushbacks, and there's actually less things you have to specify in the new graphical user interface too. It will sort of understand better what it is you're trying to achieve. Again, quality constraints. So this is from Mayo MFO. These should look fairly familiar based on what the video we've just demonstrated. So the previous global tab is on the right-hand side and the newer version is on the left. It's essentially determining your minimum and maximum tons per annum, and it gives you all the target definitions for the various stockpiles. So this is a quick timeline for NPVS Plus. It is coming. We're planning on doing, we've got an alpha version out at the moment. That's what those screenshots were. So our beta version is coming out end of June, start of July. Our commercial version is coming out in August. So that'll be the brand new 1.0. If you would like to test these, please get in contact with us. We're more than happy to have beta testers. And if you would like Multi-mine support, haulage analysis, improved scheduling reports, and additional scheduling controls, that will all be out in Q1 of 2026. So additional information will also be made available prior to the release date of Studio NPVS Plus.